All right, so section 3 is elementary probability. You can think of a probability as a fraction of the number of outcomes that you're looking for divided by the total number of outcomes. So if I roll a 6-sided die and I'm looking for a 3, right? There's 1 3 that I'm looking for out of the 6 numbers there. So 1 out of 6 would be the probability of getting a 3, right? Your numerator has to always be a subset of the denominator. So your numerator can never be larger than the denominator, and because of that, you can't get a probability bigger than 1. 1 is the max that you can get, and if you get a probability of 1, that means that it will always happen, or it will happen for sure. The worst case scenario is that you get 0, probability of 0. That's the lowest probability you can get. You won't get a negative probability, and that would mean that whatever we're looking at is impossible, or it will never happen. In most cases, your probability will sit between 0 and 1. It won't be 0 or 1. So let's take a look at number 1 here. So for each of the following events, an event is kind of what you're looking for. We got 3 events, A, B, and C. List out and count the number of outcomes that event contains, and then calculate the probability. So on part A, I want to throw a 3 or a higher and with 1 die. So 3 or higher would mean which numbers? 3, 4, 5, or a 6, right? So all of those, any of those, I would be happy with, and they would meet the requirement of event A. So if I were to find the probability, so P representing probability of my event A, I'd say, well, I have 4 outcomes in that event. And how many total outcomes when I roll a die? 6, so it'd be 4 out of 6, which is 2/3 reduced. Part B, I want to throw exactly 2 heads when I flip 3 coins. Okay. So how many different possibilities would fit in that event? So one case would be HHT. First flip is a head, second one's a head, the third one's a tail. I could also do HTH or THH. Is there any other scenarios that would fit? Okay, so there's 3. So what's the probability of B? What is it? I need your counting skills now. So we know it's 3 out of how many total possibilities? If I flip 3 coins, how many possibilities, guys? 6, 8, 9. Hearing different options here. So we need to know how to count, right? So if I have 3 coins, I got 2 possibilities for my first flip, times 2 possibilities for my second, times 2 for my third. That gives me 8 possibilities total. So it should be 3 out of 8. Okay. And if you're unsure, you could list out all possibilities, and you'll see there's only 8. Okay. And then how about part C, throwing a total score of 14 when you roll 2 dice? So you're gonna roll 2 dice, you're gonna add up what you have. What's the probability of getting a 14? Answer? Can't happen, right? So our event C, we say, is our empty set, meaning that there are no Um, there are no options. Empty set is denoted with the kind of an O with a slash through it. That is not the number 0. I don't think anybody does, but if you make your zeros look like that, don't do that, because that is reserved for empty set or no solution. Okay. So the probability of C is going to be 0 over, what are the total number of possibilities here? Good. 6 times 6, 36, which is still 0, but again, practice our counting, right? Got 6 options times 6 options. Number 2, I'll leave for you to do. Let's try number 3, though. I'm gonna let you work ahead of me. 3 coins are thrown. List the outcomes which belong to each of the following events. Okay, so how many options do we have for 2 tails? What do you guys get? 3 options. Good. How many for at least 2 tails? What was it? What do you guys get for B? So it's just counting. So it's going to be like 1, 2, 3, 4, 5. It's not going to be a fraction. So not looking for a probability. So how many different options for at least 2 tails? What does it mean to have at least 2 tails? At least 2 or above. So in this case, there's only, you can go up as high as 3. So 2 or 3, right? So what did you guys get? 4. All right. At most 2 tails, 2 or below, how many are we getting? 7. Okay, so here's what they look like. There's 3 ways to get 2 tails. There's 1 way to get 3 tails. There's 3 ways to get 1 tail. And there's 1 way to get no tails. All right. Some are still writing something down, but just see how you guys are doing. If I flip a coin 5 times, what's the probability I get all tails? Flip a coin 5 times, probability I get all 5 tails. No? So there's a probability of something over something now. Got a fraction. How many different ways can I get all tails? 1 way. How many ways can you flip 5 coins? No. 2 times 2 times 2 times 2 times 2, which is It's 32 ways, so 1 out of 32. Okay. All right. So those are some coin problems. We're going to now turn our attention to some dice problems. 4 and 5 I'm going to leave for you, but let's do number 6 together. Now, when you're rolling 2 standard dice and trying to organize all the different possibilities, sometimes it can be a little tricky. And so I'm going to show you one way to organize the data. It's not something you have to use, but if you're unsure, it's the safe way to go. Okay, so I'm gonna at least give you a safe way to go when you're dealing with 2 standard dice problems. So it's create a table. So your first die can have options 1 through 6. And the second die you roll can also have options 1 through 6. And some of the 2 dice problems will say, hey, talk about the difference between the 2 that you roll. And then what you could do is find all your differences in there. Or some will say find the sum. You can put your sums in there. Some will say find the product. Others they'll vary. Okay. In this particular problem, it's talking about the sums. Okay. And so what I'm going to do is I'm going to treat it like an addition table. So 1 plus 1 is 2, 1 plus 2 is 3, and so on. And so in this table, you could see all the possibilities and all the sums that come out with those possibilities. And you can see that some sums are more frequent than others, and there are games that involve lots of games out there that involve rolling dice. My family played one last weekend. Maybe Settlers of Catan. Maybe you've heard of that. Maybe not. Anybody played that one before? No. Anyhow, there are games that involve rolling dice, and knowing that 7 is the most likely outcome, 12 and 2 are the least likely sums. It can be helpful. Or even if you're creating your own game, that can be helpful, right? So I'm interested, though, in getting a sum greater than 3 and less than 11. So it needs to meet both those requirements. So that's talking anywhere between 4 and 10. So what's my probability going to be? Okay, so you got 30 numbers that are highlighted out of the 36. Is there an easier way instead of having to count all 30 of those numbers? It's called the backdoor approach. Count the ones that aren't highlighted if there's fewer, right? There's 6 that are not highlighted. So you could do something like this. Well, I know there's 36 total minus the 6 over 36. You still get 30 over 36, right? And both those reduce to 5 out of 6 for an answer. And if you look at your answer choices at the bottom, you don't see 5 out of 6, do you? So that's because they goofed up on that one, and so we're gonna change our answer choices here real quick. So change that last one says 35 out of 36. Cross out the 3's, make it 5 out of 6. Now we have it. Okay. All right. Next one I want to do with you guys, but I want you to work ahead of me, is try number 9. What are we getting for number 9? 3/4? Correct. We're getting 3/4. We're on the right track. So let me suggest a couple ways. So first of all, the work, the one involving the least amount of work, okay, but more thinking. The more thinking you want to do, the less work you want to do, the more thinking you got to do. Okay. So if I want the product of two numbers to be even, how do I get a? What does that tell me about the two numbers in terms of being even and odd? Like, if I have an even times an even, I get what? Even. If I do even times odd, I get even. Odd times even is even. And then odd times odd is odd. So evens, there's more cases. It's more complicated. And so it's nice to pick the easier route. So it's easier to count the odds for me than it is to count the evens, because I have more cases with the evens. So if I go with just the odds, well, how many odd numbers on a die? 1, 3, and 5. So 3 odd numbers. So I have 3 choices and 3 choices. 3 times 3 is 9. So I've just counted how many odd combinations. So 36 minus 9 out of 36, 20, and then I got it. Right? So that's the method that involves more thinking. If you weren't confident in that and you wanted a safe approach, you could do this. It'll still work. There's nothing wrong with it. And, you can always fall back on this. So this is a way to organize all your 36 outcomes, and you'll get 9 odds. And then you can go about it that way. Okay. All right, one last one I want to do with you. Go ahead and do number 13. Again, try it without me. The first thing you got to understand is how many powers of 2 there are. And on one die, how many powers of 2 are there? What are they? 2 is a power of 2. Just 2 to the power of 1. 4 is a power of 2. That's 2 to the power of 2. There's one more. 1, which is 2 to the power of 0. Okay, so there's 3 powers of 2, and you got to know that first, right? Otherwise, they'll throw your problem off. And probability is the number of outcomes you want divided by the total number of outcomes. And you see my fraction here, 27. So there's 27 outcomes that I would take out of 216. How am I getting 216? So there's 6 options on each of the 3 die. That's how I'm getting my 216. How am I getting my 27? Well, there's 3 powers of 2 on each of the die, and I want a power of 2 on each one. So 3 times 3 times 3. And so that's how I'm getting that. Okay. So I'm going to stop there. The section itself goes all the way to 26, but it's not due tomorrow. Okay, but you want to start working through as many as you can with what time you have. I'll take a couple questions tomorrow and stuff you get stuck on, but you're going to have today and tomorrow kind of to think through this topic before we add more to it. Okay. So again, understanding is really important for you guys.